Hi there and welcome to this Python video tutorial on control flow. So if you saw the previous tutorial on functions, you'll remember that we built two simple functions to calculate the area of a circle from its diameter, this function here, and also the area of a circle from its radius. Now these are very simple functions that really just solve a single equation. And what we're going to look at today is functions that start to get a little more complex, and in particular functions that, rather than simply solving an equation, actually do execute an algorithm. And so these functions are this function we're going to build in this tutorial is going to have some different options, meaning that it's going to do some things in some scenarios and something else in another scenario. But before I get into too much detail explaining that in general, I'm going to use a specific example to motivate it. So we're going to try and solve a particular problem. And the problem we're going to try and solve is this. Imagine that we've got a beaker containing water, and the beaker is 15 centimeters tall, it's 10 centimeters in diameter, it's a cylindrical beaker. And then imagine, and the depth of the water is 10 centimeters. And then imagine that we want to drop a ball, a sphere, into the beaker. And it's heavy, it's a heavy sphere, it's going to sink, it's denser than whatever it's made of, lead or something, it's definitely denser than water. We want to know, for a sphere of given radius r, will the water overflow the beaker due to the displacement of the sphere being dropped into it? Okay. And we want to create a function in Python that is just going to answer that question, sort of a binary yes or no. Will it overflow, won't it overflow? Okay, so if we go back to our script, I've added a third function to the two that we created in the previous video tutorial, and this one calculates the volume of a sphere from its radius. Very similar to the circle area from diameter or circle area from radius functions. It just calculates a simple equation that gives you the volume of a sphere. 4/3 pi r cubed is the volume of a sphere from its radius. So the function we want to create, I've just created that because obviously we're going to employ it. It's going to come in handy. So I'm just going to talk you through how I would solve this problem. So we'll create a function called does my beaker overflow, and we'll give it the radius of a sphere. So if we drop a radius of a sphere in this beaker, will it overflow? And we'll give it a documentation string, which would say something like returns true if a sphere of radius r causes the beaker to overflow, returns false otherwise. I'll say. Okay, so the first thing to do in here, I want to create some variables for the information we got. So we were told the beaker diameter was 10 centimeters. I'm going to introduce another type of comment here. We've looked at comment strings, which are these sort of doc strings here. There's another way. If you want to, on a particular line, if you just want to write something to remind you what that is, you can use this hashtag symbol, and then anything I type after that Python will ignore. So I might just type here diameter of beaker in centimeters. Okay, just so I know what that is. And then we'll have h equals 15 centimeters was the height of the beaker, and we'll have w equals 10 centimeters, and that was the water level in the beaker. Okay. So the beaker will overflow if the volume of the sphere is greater than the empty spare volume in the beaker. So the sphere will displace water equal to its volume, so the water level will rise accordingly. And if the volume displaced is greater than the spare volume in the beaker, then the beaker will overflow. So the first thing we need to do is calculate the spare volume in the beaker, which will be the cross-sectional area of the beaker times the height of the beaker minus the height of the water. Okay, so the spare volume, in fact maybe we should calculate the cross-sectional area first. Cross-sectional areas. I'm creating a variable called cross-sectional area, and I'm going to assign that a value, which is the cross-sectional area of the beaker. And we've already created a function in the last video tutorial that calculates the circle area from diameter. So I'm going to use that function here. Circle area from diameter d. Okay, so that's d here is our diameter. Okay, so that's going to calculate the circle area, and the spare volume will be equal to the cross-sectional area. I'm going to use copy and paste here rather than typing that all out again. Also mean spare volume equals cross-sectional area multiplied by the height of the beaker minus the width of the beaker. No, sorry, width. W. Minus W, which is the water level. So there's 5 centimeters of spare height. So it's basically the cross-sectional area of a 10 centimeter diameter circle times 5 centimeters in this case. And I also need to know the volume of the sphere with radius r. R is passed to the function here. So we'll calculate the sphere volume. Equals, and we'll use this predefined function we've already created up here, okay, which calculates the volume of a sphere. So we've now got ourselves in a position where we can answer the question, does the beaker overflow or doesn't the beaker overflow? So the beaker will overflow if the sphere volume is greater than the spare volume. And what we want our function to do is we want our function to return a Boolean variable. You'll remember if you saw the video tutorial on types and operators, we discussed in that video tutorial a primitive type called a Boolean, which is true or false. And if I just type in the console down here, if I just remind you of that, if I create a variable called y and I can assign it a value true, and that's a Boolean variable. Type of y is bool, and the value of y is true. And similarly, I can create something that's false. Now that actually is going to come, the Boolean variable is going to come in very handy in this function in a couple of ways. One, it's going to be what we return, but it's also going to help us decide, it's going to help us tell the function whether to return true or false. So what we want to do is we want to evaluate whether the sphere volume is greater than the spare volume, and if that is the case, we'll return true, and if it's not the case, we'll return false. The beaker won't overflow. Okay, so the way we do that is using control flow, and the syntax for that looks like this. So I'll type if the sphere volume is greater than the spare volume. Okay, and then this is a bit like, this has got a similar syntax to the to a function definition, in that afterwards we put this colon, and then we hit return, and you'll notice that Spider has automatically given us another tab. Okay, so we've got 2 indents now. We've got one indent for the function and another indent for this if statement. Now what happens here is any code that I write under here that's indented will only execute if this statement is true. So in other words, if the sphere volume really is greater than the spare volume. So any code I type in here will only be executed if that is true. And if I go back and get rid of the indentation, then any code I write here will be executed regardless. Okay, it will be executed every time the functions run. But any code that's indented under here will only execute if this statement is true. Okay, so the if keyword, following the if keyword, you need to have some kind of statement that evaluates to true or false. And what we've used here is something called a Boolean operator, this greater than. And if I just show you how this works down in the console down here, if I create, well, I don't even need to do this. So I just put in a simple statement like 10 is greater than 5, and I hit return, you'll see that Python interprets that statement and returns true. Okay, but if I put 5 is greater than 10, then I get false. Okay, and so the types of statement you can get here, there's a number of different types of statement for evaluating numerical values. So obviously we've looked at greater than, obviously there's also less than, the arrow going the other way. There's greater than or equal to if you want to be a little bit more precise. So we can have 10 is let's do this. Let's do 5 is greater than or equal to 5 will obviously evaluate as true, but 5 is greater than 5 will obviously evaluate as false. And you can obviously do it the other way around. You can do 5 is less than or equal to 5. And you can also evaluate whether two values are truly equal by using this syntax, 5 equals 5. It's like a double equals sign. And it's kind of important that we do that rather than just saying 5 equals 5, because as we've looked at, we get an error if we even try it. If we've looked at in previous tutorials, the equal sign in Python and computer programming languages in general doesn't really mean equals, it means assignment. So this statement means we're assigning the value 5 to the variable a. Whereas this statement means is 5 exactly equal to 5? And of course that's true. Okay, so here we've used if the sphere volume is greater than the spare volume, then I'm going to create a new variable here called overflows, and I'm going to say it's equal to true. In that case it will overflow. So overflows, the variable overflows will get set to a Boolean variable with the value equal to true if the sphere volume is greater than the spare volume. Now what we really want to do here then, so that code will only happen if that is true. And what we want to do here now is have basically the opposite case taken care of. If the sphere volume is less than the spare volume. And so I'm going to use here another keyword called else. Okay, and in here I'm going to put overflows equals false. And then I'm going to get rid of the indent because I want this final line of code to be executed regardless, and that is I'm going to ask the function to return the variable overflows. Okay, so I'll save that, I'll run it. Of course nothing's going to happen because all I've done is define functions. I haven't called any functions yet. So just to test, I'll go down here and I will do a function call, and I'll create my I'll create a variable called answer, and I'll say I'll use copy and paste rather than type that all out. And what we'll do is we'll test this, we'll see if this works, and we'll test it for a value of a sphere of radius 4 centimeters. Okay? Right, I'll save that. I will run, I can step, as usual Python will just ignore all these functions, we'll step over them, we'll get to the function we want, to the line that we want to execute. Does my Beaker overflow? I'll step in, and let's see what happens here. We'll watch the variable explorer and we'll just go through it step by step. So, first of all, oh, hang on, I'm gonna stop this. First of all, let's clear our workspace. There's a bit annoying stuff in there already. We'll get rid of that. Okay, let's try again. I'll run, we'll step into the function. Okay, so we're in this function now, does my Beaker overflow? The first thing it does is going to create these variables d, h, and w, so we see in memory. We've got r, of course, the radius of the circle, which was passed into the function here, 4, and we've got our various heights. The next thing it's going to do is it's going to calculate the cross-sectional area. So we've got this new variable appeared called cross-sectional area, 78.55. It's going to calculate then it's going to have an error. Global name cross-sectional area is not defined. Right, so I've done a typo here. I've got a bug in my code. Basically, I meant to say this and I've typed cross twice. Okay, so my code hasn't run correctly. So I'm going to fix that bug. Okay, so that's now repaired. So those are now the same. So this code should now execute correctly. And I'm going to try again. Right, so run, step in, define D, H, and W, define cross-sectional area, define the spare volume. So the spare volume is 392.75 cubic centimeters, I guess. And the sphere volume is 268. So we already know the answer by looking at these. By looking at this, we already know that by looking at the sphere volume and the spare volume and the sphere volume, we see that the sphere volume is less than the spare volume. So the ball will drop into the beaker and the water level will rise, but it won't actually overflow. But we need our function to get that right and return the correct answer. So if we look in here, it's gonna test. We're now on this line here, line 39, if the sphere volume is greater than the spare volume. And if I press step, you'll notice that it's dropped straight down to line 42. Basically that was false. The sphere volume is not greater than the spare volume. So it drops down to this one, else, and else catches everything else. Okay, so anything that doesn't drop into here goes in here. And then this line of code executes. Okay, return overflows. So then we return, and then dropping it back into here out of the function space, the only thing we've got is our answer, which is a Boolean variable called false, because the sphere doesn't overflow. And also what we could do here, for completeness, is we could print the answer out, and it would also come out here. So if I just stop that, if I just run the whole code, so it will print out false. If I try for a larger sphere volume, like 5, or radius of 5, and then I press run, the answer changes and I get true. And we may as well step through that and see how that works. So if we step down here, step in, define these. Okay, so now we see that the spare volume is 392 and the sphere volume is 523. So this time the sphere volume is bigger and it's going to overflow. And so at this point, if I press step, we will drop in here and we will execute this line of code. Overflows equals true, which means that we won't go into else. Okay, so it's either that, it either executes this line of code or this line of code. This line of code if that statement is true, that line of code if it's not. And this time it returns overflows true. Okay? So that seems to work, except there's a slight problem in that, let's say, what if I put in a very large sphere volume, like 25, and I press run? Well, that's going to return true, but that actually doesn't make a lot of sense in the real world, because yes, the volume of a sphere of radius 25 centimeters is going to be bigger than the spare volume in the beaker, but the beaker's only got 10 centimeters diameter, so actually that sphere's not even going to fit in the beaker. So it'll be difficult to make it overflow. So what we want to do actually is we want to get this function to return false if the sphere doesn't fit in the beaker, right? Because if the sphere doesn't fit in the beaker, it's not going to go in and it's not going to make the water overflow. And actually, let's think about this. I want it to test that first of all. I want it to test that before it tries to do the volume test. So we actually want three options. We now want one of, it can, here we could be in one of two situations. Now I want to actually be in one of three situations, and I'll show you how we do this. So I'm going to start up here with if, so let me see the diameter. So if 2 times r, which is the radius of the sphere, is greater than, I'll put that in brackets just to make sure, 2 times r, that's the diameter of the sphere, is greater than d, the diameter of the beaker, then I want overflows to be equal to false overflows. False, because it doesn't fit in the beaker. And what I need to do here is I need to change this slightly to look like this. Okay, so I now have if, elif, which is short for else if, and else. And the way this works is it tries to execute these statements in order. If this statement is true, it will, overflows will equal false, and then it will jump down to the end below all these elif and else statements. And then if it's false, it will then move on to the next one and test it and see if that one's true. And actually, you can have any number of elifs. So I could have another elif. I could use, so if you've got something with one of 5 or 6 options, you just keep adding elifs, right? And it keeps testing each one in turn until it finds one that's true. And when it finds one that's true, it executes the code and then it drops out to the end. And it only makes it to this else statement if it's tested all ifs and elifs and none of them are true. And this is quite important, and the order is quite important as well, because if in the case of the beaker volume being 25, this statement is true, but this statement is also true, which is why I wanted to put this one first, because these give different answers. So this one sets overflows as false, this one sets overflows as true, even though both these things are true in the case of a radius of 25 centimeters, a very large sphere. So I want it to test the diameter one first, because I want that one to supersede. So even though this statement is true, it won't execute if this one's true. So the order in which you place these ifs and elifs is important. Okay, so let me show you this running. Okay, so we'll save that. We'll run step, 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 step in. Okay, so here we go. So the sphere volume is giant. It is definitely bigger than the spare volume, but also the sphere doesn't fit in the cup. So that will be true. Overflows will be set to false, and as soon as that's happened, notice that my cursor then jumped immediately down to the return statement. Okay, and it didn't even try and execute any of these elifs, even though that one was in fact true. So the order here is important. If you use if and elif, it will only execute one of these three, or if I had more, it would only execute one of these options, the first one it comes across which is true, and then it will ignore all the others, okay? And that behavior is important. Okay, so that's a quick overview of, we might as well just run that just to be sure. So now, before when I had 25 centimeters and I ran it, I got an answer saying true, whereas now if I run it, I'll get false. So that's kind of fixed that problem. And if I put, what we did 5 before, so that actually, our one that we did before only just fits in the beaker. So that should return true. And if we do, I don't know, something slightly smaller, 4.7, that should give us true. And what did we have before? 4.5, let's see what that is. False. Okay, so somewhere in that region you've got you've got the tipping point where it flows or doesn't overflow. Okay, so that was kind of hopefully that was sort of a practical example, an example of how to solve a little practical problem. We've used Boolean variables. We've returned a Boolean variable, true or false, but we've also used Boolean variables in the evaluation of these statements, these if-else statements, and that's how you do control flow. All right.